Let's look at this one as we go through. Okay, as we look at this problem, let me see if I can zoom in here a little bit. Solve ax minus 3x plus 5 equals a plus b for x. So what that means is we're going to want to move everything that we have that's not attached to the a to the other side. So if I look at this, ax minus 3x plus 5 equals a plus b. Do I have anything? I want to isolate all of the variables that have x in it. So these two I'm going to keep on this side for now. Does the 5 have an x in it?
No.
No, I'm not multiplying anything here times 5. So what could I do to move this to the other side of the equation? Subtract 5 from both sides.
Wow. Is it supposed to be moving that slow?
Yeah, it does that.
It's lagging.
Okay. Ax minus 3x equals a plus b minus 5. Now, what can I do? Notice I'm multiplying a times x and 3 times x. Could I factor those out? Can I factor those out? So I'm going to pull those out, and I have x times a minus 3 equals a plus b minus 5. Now, if I were to distribute that x, it would leave me with ax minus 3x, which is what I started with in this line right here. Do you see how that works? Okay. Now, I'm multiplying a minus 3 times x. So how would I get rid of that a minus 3? What's the opposite of multiplication? Division. So I'm going to divide by a minus 3, which means I'm going to divide this side by a minus 3. Now these two will cancel out, which is going to leave me with x equals a plus b minus 5 over a minus 3. Well, I just wanted to solve for x, so that would be where I'd stop. Now, it did ask me for restrictions. What's the only number that we can't have as a denominator? It's going to give me something called undefined. Okay, I can't use 0 as a denominator. So in this case, a couldn't equal what? If a equaled 0, on my denominator it'd have negative 3, which would be okay. I cannot have the denominator equal to 0. So what number could not equal 3? There you go. A cannot equal 3. So that would be the restriction. Does that make sense?